Here are the solutions for calculus homework number 17 from the textbook. So number 1 here gives us a graph of cost and revenue for a particular company. A asks us, what quantity does this company have to produce in order to make a profit? Well, as we discussed in class, in order to make a profit, we are going to need to have more revenue than cost. So if we look at this point where these two functions intersect, that would be the point where our company starts to make a profit. So we're estimating here, each of these tick marks is 100. So we might say that this is around 330, give or take. You may have something slightly different as your estimate. That's just going to be mine. So for B, again, I'm making an estimate. I want to know the profit generated by 600 units. So just a quick reminder that profit, as we described it as pi, is going to be the difference of revenue minus cost. So if we want 600 units, we want to find the difference between the functions at 600 units produced. So the difference here, well, let's assume that this revenue function is slightly below 2,500. So let's say it's about 2,400. And the cost function, we'll have another conservative estimate of maybe 1,700 or 1,750. So I would say that as an estimate, the profit produced when you generate 600 units and sell them is about 700, and this is in dollars. So that's all there is to number 1. Number 4 says, here are my cost and revenue functions in dollars. So I have CQ, which is 6,000 plus 10 times Q, and my revenue function is 12Q. So I want to find the cost and revenue if the company produces 500 units. Then I want to know if it makes a profit. So C of 500 is just going to be 6,000 plus 10 times 500. So this is just simply $11,000. Then for my revenue at 500, I will just have 12 times 500, which is just a simple 6,000. And so does the company make a profit? No. No profit here. And the reason for that is cost is higher than revenue. So no profit if cost is higher than revenue. If they make 5,000 units, we need to make this comparison again. So C of 5,000, if I go ahead and plug 5,000 in here, it's going to be 5,000 times 10, which is 50,000. So this is 56,000 as my cost. And my revenue for producing and selling 5,000 units is going to be 5,000 times 12, which is 60,000. So at this point, revenue is greater than cost. So I'm making a profit of about $4,000. So the break-even point is when these two are equal. So when is C of Q equal to R of Q? So if I set these two functions equal, so 6,000 plus 10Q equals 12Q, and I'm solving for Q here, so I'm going to have 6,000 equals 2Q, because I'm subtracting 10Q from both sides, then dividing both sides by 2 gives me that Q would be equal to 3,000. So this is my break-even point. How does it look graphically? Well, if I put both of these on the same function, so I have just money on the vertical axis as opposed to specifically cost or revenue, then this is going to look where my cost starts at 6,000 and increases by 10Q. So we'll say it starts about right here and then increases. And then my revenue starts at 0, but increases at a faster rate. So it should look something like this. And the point where these two intersect should be when Q is equal to 3,000. And that's all we need to do to illustrate this graphically. Number 8 says an amusement park charges a admission fee of $7 per person. Pardon me for changing colors here. So an amusement park charges an admission fee of $7 per person, as well as $150 for each ride. So this is number 8. For one visitor, we want to find the park's total revenue as a function of the number of rides taken. So this is where we're generating a revenue function, so R of n, as a function of number of rides taken. So this is going to be revenue per person times the number of rides. So if we do the rides bit, we know that this is just 150 times n. Right? This is my revenue per ride. And so for one single person, it's going to be 150 times the number of rides plus $7. So this is for one single visitor. Now, R of 2 is just going to be 150 times 2 plus 7. So this person rode 2 rides after buying entry to the park, and so they spent, their revenue for the park was $10 for this person. By comparison, if they ride 8 rides instead of 2, then the park is making a revenue of $16. I'm sorry, not $16. That would be $19. So, in this case, we're making more money because this person is riding more rides. Now, for number 11, we have a little bit more going on. So, for number 11, we have a cost function. C of Q is 4,000 plus 2Q. And a revenue function, which is just 10Q. A asks, what are the fixed costs? Well, the fixed costs are the constant in our cost function. So for us, that is just this $4,000. The marginal cost, remember, is the cost to create one more thing. So for this cost function, I can think of it as the original equation, which is C of Q plus 1 minus C of Q. And that would just look like this, 4,000 plus 2 times Q plus 1 minus 4,000 plus 2Q. So if I go through this process, I see 4,000 plus 2Q plus 2 minus 4,000 minus 2Q. And so I see that 2Q goes away, 4,000 goes away, and I'm just left with a marginal cost of 2. I will remind you, however, that for a linear cost function, the marginal cost is simply the slope of that cost function. So, for C, it's asking you to interpret the revenue function. So what price is the company charging for its product? Well, it appears that for our revenue function that has a slope of 10, it is charging $10 per item. And again, that is from the slope of my revenue function. D asks us to graph these on the same axis and label the break-even point Q, and you would pronounce this Q0 or Q0. And explain how you know the company makes a profit if the quantity produced is greater than this. So let's sketch a quick plot. So here is our axis for money. Here is our axis for quantity. So our cost function, we'll go ahead and do in red, would look something like this, where it starts very positive at 4,000, and it has a slope of 2, which is very slight. And compare this to our revenue function, which is going to be positive 10 in slope. And so somewhere these two will meet, and we'll call this Q0. as it asks us to do, which is our break-even point. And so now all we need to do is find this break-even point. So our break-even point is when our cost function is equal to our revenue function. So we're going to set C of Q equal to R of Q, which is 4,000 plus 2Q equals 10Q. So I'm running out of room here. I will subtract 2Q from both sides, so that gives me 4,000 equal to 8Q. Then I will divide both sides by 8. And so 4,000 divided by 8 would give us a Q value of 500. So this is my Q naught, which is my break-even point. That's the quantity I need to sell in order to begin making a profit. Number 12 asks us to look at this table where we have values of Q and we have a cost function. So the fixed cost would be how much money we have spent before we sell anything. So this cost before we've sold anything would be our fixed cost. Our marginal cost, remember, is the price to sell one more item. So here I can see that after selling 5 more items, my cost has gone up $20. So my marginal cost appears to be 20 per 5 items, or $4 per item. So if I wanted to write this as an actual equation, I would probably write it as 4Q. So my cost function in the end is going to be my fixed cost plus my marginal cost. So that would be 5,000 plus 4 times Q. For 15. So production costs for manufacturing running shoes consists of a fixed overhead of $650,000, so this is a fixed cost, plus variable costs of $20 per shoe. We sell each pair of shoes for $70. So part A just asks us to find a cost function, a revenue function, and a profit function as functions of the number of pairs of shoes produced, which is Q. So I'll start with my cost function. So my cost function has a fixed cost of $650,000 plus an additional 20 per pair of shoes. And so this is my cost function. My revenue function is a simple one, so it's just $70 per pair of shoes that I sell. So my profit function, again, is going to be the difference in these two. So CQ minus, I did this backwards, be revenue minus cost. So for us, this would be 70Q minus 650,000 plus 20Q. So my profit function would end up being 50Q minus 650,000. Which it tells you that we're going to be making negative profit until 50Q is equal to 650,000. So for B, it asks us to find marginal cost, marginal revenue, and marginal profit. So marginal cost is just going to be how much does it cost to make one more shoe or one more pair of shoes. So again, we don't need to do any math. We have a linear cost function. So my marginal cost is simply the slope of that cost function. So it's just $20 per pair of shoes. My marginal revenue, same deal, right? How much more money do I make from selling one pair? Well, it's 70 per pair, so one more pair gives me $70 more. Then my marginal profit is not something we have talked about necessarily. But how much more money would I make in profit per shoe? So again, I look at my profit function and see that it is linear, and that implies that the slope of my profit function tells me how much more profit I make per shoe. So my marginal profit is simply $50. Now, the last part of this question asks us to see how many pairs of shoes must be produced and sold for the company to make a profit. So we can do this two ways, but the easiest way, since we've already come up with a profit function, is to just say, when does our profit start to become positive? And that happens when it goes through 0. So I'll just set this equal to 0, set my profit function equal to 0, that is, and I'm going to solve for Q. So I have 50Q equals 650,000. And if I divide both sides by 50, then I see that Q will end up being, let's see, that's difficult to do in my head, so I'll just go ahead and use a calculator. 13,000. So I will need 13,000 shoes sold before I start to turn a profit. Moving on. Number 17 asks us to look at this table again, and looking at both cost and revenue based on quantity, we want to see what range of production levels that appear to be profitable. So we want to know when revenue is greater than cost. So when is revenue greater than cost? Well, it appears that revenue is greater than cost starting at Q equals 20 and going up until Q equals 60. At that point, revenue becomes lower than cost. Now, part B asks us to calculate the profit or loss for each of the quantities shown and then estimate the most profitable level. So, we're just going ahead and making a table for this. So, we have a quantity, which this row will just be the quantities from above. So that will be 0, 10, 20, 30. I need to make this smaller, I'm sorry. 0, 10, 20, 30, 40, 50, 60, and 70. And then our profit or loss, so we'll just call our profit negative loss, or sorry, our loss as negative profit, would just be the difference between cost and revenue. So if we sell 0, then we lose $120. If we sell 10, revenue minus cost gives us a loss of $100. If we sell 20, no loss or gain. If we sell 30, 900 minus 780 gives us positive 120. If we sell 40, positive 200. If we sell 50, positive 180. 60, again, we're breaking even. And then at 70, we are actually losing $400. So the most profitable production level appears to be right here when we produce 40 shoes or 40 quantities of some item. When we have the most positive profit. Now, we have one more question, which is 18. And it says, give an example of a possible company where the fixed costs are 0 or something that's very small. So you can really come up with anything here. If you have a question about whether or not your company has a fixed cost of 0, please let me know. Another question here is, when are marginal costs 0? So really, a fixed cost company that has 0 fixed cost is something that there's no buy-in. You don't need a lot of equipment in order to get this product produced. Or there's not a lot of investment necessary. So maybe you're selling ideas, something of that nature. As far as marginal cost goes, you don't need a lot of materials per item. So again, if you have any ideas that you want to double check, please go ahead and just let me know.